Olá, espaçonauta! Pessoal, eu sei que eu prometi para vocês hoje um vídeo sobre a abertura da cápsula lá com as amostras da CHANG E 6, né? Só que o Alfredo me enviou esse vídeo aqui, que é um vídeo incrível, que foi publicado ao vivo no dia que chegou a cápsula com as amostras, e eu quis trazer para vocês terem uma ideia de como que a Agência Espacial da China está agindo. Aqui a gente tem uma explicação, na verdade é uma entrevista feita pela equipe de reportagem científica da CGTN. CGTN é uma TV lá, estatal da China, tá? Com o Dr. Yuguang e o Yuguang. Ele é vice-presidente do comitê do programa espacial chinês. Seria mais ou menos um vice-presidente da NASA da China, para que vocês entendam. Cara, eu tô apaixonado com esse vídeo, por isso que eu tive até pressa de trazer ele para vocês. Você quer entender como é que funciona uma missão lunar, as dificuldades, como que acessa a Lua, como que faz? Assiste esse vídeo até o final. Vocês vão ficar maravilhados. A aula do Dr. Yuguang, a didática, é muito semelhante ao que a gente está acostumado a ver aí com os programas da NASA, explicando sobre as missões. E é legal a gente ver isso aqui, para a gente ter essa outra dimensão de que todo mundo sabe fazer legal e sabe divulgar e sabe fazer. Nossa, assim, para mim essa palestra do Dr. Yuguang aqui, ela fechou um ciclo da missão CHANG E 6 de uma forma magnífica, até porque o que ele coloca, alguns conceitos que ele coloca aqui, não se aplica somente a CHANG E 6, mas sim a todas as missões as missões lunares. Eu estou no sol já. Se aplica a todas as missões lunares. Então, galera, é um material incrível, tá? Lembrando que esse vídeo é mais uma tradução feita aí pelo nosso amigo Alfredo Lopes Morais, lá de Portugal, tá? Que colaborador do canal. E eu vou te falar, viu, Alfredo? O que você tem contribuído para esse canal crescer e para trazer informações precisas para a galera aqui é uma coisa incrível. O seu trabalho junto ao nosso canal aqui é assim. Hoje eu considero a sua parceria como... Não tem como ter o Nerd aos 50 sem o Alfredo, viu? Muito obrigado por tudo isso, Alfredo. E aí, galera, vamos mandar um salve para o Alfredo aí, que ele tá trazendo pra gente uma informação. E ó, vou falar pra vocês, esse aqui eu posso falar, canal nenhum no Brasil transmitiu esse material. Então assistam, divulguem, compartilhem, porque isso aqui é de extrema relevância para quem curte a questão da Lua, tá certo? Vamos lá então?
Hello and good afternoon from Beijing, and welcome to our CGTN's live show, the Hype, and we are now at the CGTN headquarters in Beijing with all of our two colleagues today, and today we're going to talk about some of the most exciting moments in the human's history. And just 1 hour ago, the Chang'e 6 mission, just to bring back the human's first ever lunar soil sample from the far side of the moon, and that means for the very first time, human beings are capable of sending up the robots to the far side of the moon and take the lunar soil sample and put that into that box and flying back to home. So that was a very, very exciting moment. And we're going to discuss every details about this mission, about a lunar soil, about the moon and humans' future, with, of course, our guest today, Dr. Yuguang is our old friend, and he is the Vice Chair of the Space Transportation Committee of IAF. And welcome, Dr. Yang. It's been a very long day for you, huh?
But a very happy day.
A very happy day. You said you get up at 5 o'clock this morning, and you've been involved in...
Actually, 3:45.
That's right. And you've been, Dr. Yang, been involved in many multiple programs and different kind of media. And we're talking about this. So that means everyone here in China and around the world are anticipating for this lunar sample coming home, the journeys to coming home. And also joining us is my colleague Meiping is from CGTN's science reporting team. Hello, Meiping.
Hello everyone, I'm Meiping, and today we're going to dig into some key questions of China's lunar programs.
Exactly, and our discussion is oriented by all of your questions.
Right. So we're going to answer some questions you may have about China's Chang'e 6 lunar mission and also China's lunar exploration program. So please share your questions with us. And before everything, we want to show you an AI-assisted animation about Chang'e 6 journey to the far side of the moon. And if you want to watch more, you can check out our CGTN website and app. So here comes the very cute animation of Chang'e 6. Take a look.
Meiping's team have been working on this animation for quite a long time.
Quite a long time, and it's actually my voice.
Yeah,
I use my voice and mix that with AI and to generate a new kind of voice.
Have you ever recognized Meiping's voice in that? That's a cute little Chang'e's probe is actually voiced by Meiping.
I made myself like really cute, like,
right.
Like, where is this place? Yeah, something like that.
Do you use AI tools to help you to change your voice?
No, that's my real voice.
Just your real
but
voice.
Mixed with AI tools. So this is the voice for the Chang'e 6 probe. It's a new kind of voice of me and part AI.
Right. And is that the only one that we got? Is the only one episode?
No, we actually will have more episodes. So yeah, after this session, for people who want to watch more of the animation, you can just check out CGTN.com. Exactly.
And also don't forget to leave your comments on this live across, and because our discussion will be decided by you. And what kind of, it's just to throw us your question about the Chang'e mission, anything about Chang'e mission.
Yeah.
There's Dr. Yang here with us, and we talked about all of his engineering part of this mission, and also we can talk about a science part about the lunar sample soil. But very first, let's just Let's to give us a platform to Dr. Yang to give us an overview about this CHANG E 6 mission. What's this difference from the previous one, and what this CHANG E 6 mission has been through in the past month, Dr. Yang?
Well, just before this mission, about 3.5 years before, we just successfully conducted the CHANG E 5,
right,
the first
exactly.
sample return mission of China.
Yes.
That at that moment we name it as the most complicated mission of China.
I remember that.
This is because the mission profile is very, very extremely complex. I also told many times to the media that the CHANG E 5 mission can call an unmanned minimized Apollo mission. Because you know that both the Apollo missions and our CHANG E 5 and 6 missions adopted what we call the lunar orbit rendezvous. So I will talk about this later, why we choose this and why it has the highest efficiency. So let's start. So you know that, this is the Earth.
It's like taking a class.
This is the Earth.
That's the Earth. Okay, that's
the Earth. And all our CHANG E 5 and CHANG E 6 probe start from the Wenchang spacecraft launch site. So you can see, so this is the equator of the Earth, but you may notice that the China is here and Wenchang is not on the equator.
Right.
So
South China's Hainan
even
province,
for the launch of the Long March 5, we have two stages. First, you know that we launch the liftoff of the spacecraft from the Wenchang spacecraft launch site, and then with the propulsion of the Long March 5, we will first enter what we call a parking orbit. So the altitude of this parking orbit is about 170 kilograms altitude or 200 kilograms. So it is a circumorbit. But we will not stay in this orbit for a long time because it is also called a coast phase. For this coast phase, we just when we enter this parking orbit, so it will fly freely for several minutes, and then it's reach the equator. So
they will be heading the south first to the equator.
To the east, southeast. And when it is already close to the equator, we conducted the final critical step for our launch vehicle called the lunar orbit insertion. So from the round parking orbit to the translunar orbit. So you know that the reason is that we hope to go to the moon, but the moon, you know that it is in a certain direction. We must go to the right transfer orbit in the right direction. So that is why we need to wait with the rotation of the Earth. When it is in the right direction, we then launch it into the parking orbit and then accelerate it from the about 78 kilometers per second to about 10.9 kilometers per second. So at this moment, with this, also it is called can be called a perigee kick. So with this one, the final critical step of the Long March 5 rocket, it enters the translunar orbit.
So use the momentum.
Exactly.
Of the Earth.
So this is separation of the probe and the launch vehicle, and then we come into the second phase. So with this translunar orbit, it is a high elliptical orbit, very narrow and very long. The perigee is about, as I mentioned, about 200 kilometers high, but the apogee is beyond the moon. So this is a translunar orbit, usually 3 to 5 days. Why? You know that for a manned mission usually will take 3 days, because for human being we hope that the journey is as short as possible.
Exactly.
But because you know that this is a manned mission, we don't care. So what we care most is not the time, but to save the energy. So although it flies longer than the Apollo spacecraft, but it can save a certain amount of propellant. This is the translunar orbit from the Earth, goes a long way to the moon.
I just want to cut off. I was told that there are like 10 backup or 15 backup route.
Exactly. So this is called also.
So that's not the only one.
Very, very
that's
professional, you know, Mr. Yang Zhao. You know that just when the China mastered the rendezvous and the docking technology, we just there is a critical step called, you may heard that, the zero launch window, which means that the accuracy of the liftoff can be better than 1 second. But after that, we also have promotions. We developed from the zero launch window to a narrow launch window, which means that because we have the margin, we have more energy than needed for the launch vehicle. So with the margin of the energy of the launch vehicle, we can extend the launch window from 1 second to maybe several minutes. So that is why the reason that we can adopt different trajectories to, that's the launch itself is very, very critical. The weather and also the malfunction of the ground system can influence the launch. So with the narrow launch window, you can make it more chances for the launch itself. So that is the reason why we promote from the zero launch window to a narrow launch window. So after entering the translunar orbit, we also must conduct several critical steps, which is called the mid-course correction. You see that we took about 5 days from the Earth to the Moon. And during this process, even we already been very, very accurate, but still, even a very slight error can cause a very, very great deviation after 5 days. So, because it is a long journey, so we have several steps, maybe here, maybe here, maybe here, and we have 1 to 3 mid-course corrections. So at this point, we will check if the velocity and the position is okay. If it exceeds beyond the margin, we will conduct a mid-course correction to use the small rocket engines to change the trajectory slightly, and make it to ensure that it is accurate inside. So after 5 days, when it reaches the Moon, we will conduct another very critical step called the lunar orbit insertion. Lunar orbit insertion. So this is the Moon, and at this point we've already discussed it before. We choose quite different orbit comparing with the Chang E 5 mission, called the retrograde orbit. So the direction is from the west to the east, comparing with for the Chang E 5 probe from the west to the east. So it's in the opposite direction. Why do that? The reason is that our Chang E 6 probe originally is a backup of the Chang E 5. So they have similar technical specifications. But you know that landing on the Moon and the lift off the Moon, we have many constraints. For instance, we have the antennas must facing to the right direction. And also the solar panels must face a certain direction, the right direction. Because that this time we not get samples from the near side, from the northern hemisphere of the Moon, but on the far side of the Moon, and also on the southern hemisphere. So it's in the opposite direction. So if we choose the normal orbit, which means that we must change the status of the antennas and the solar panels. So to save this kind of resources,
you have to fly it another way.
Yeah, exactly. Very wise. So this time we choose a different direction to fly. Although it's a little bit difficult and a little bit more complex than the Chang E 5 mission, but it saves the resources to change the status of the hardware. So this time we can still use the similar hardware like the Chang E 5. So that is the reason we use the retrograde orbit. So at this point we have what we call the lunar orbit insertion. You know that although the Moon is much smaller than the Earth, the mass is about 80. The Earth is 81 times bigger than the Moon, but still it is a very huge celestial body. So when the probe approaching the Moon, it is accelerated by its gravity. So at the Moon, when it is near, the speed is greater than 2.4 kilometers per second, which is greater than the escape orbit of the Moon relative to the Moon. So if we do not de-accelerate the probe, it will fly by the Moon and go to other places. So we will never have the chance to meet with the Moon again. So that is the reason why we must de-accelerate the probe and at this moment from a translunar orbit to the circumlunar orbit. So that is one, and the point is you only have one chance. So that is why it is so difficult and dangerous. And also many countries failed as they first reduce its what you call the perilunar or periselene to about 15 kilometers. So it reduced the speed and then it changed to an elliptical orbit. The lower part is about 15 kilometers. Then we start the landing process from this point, the 15 kilometers. And it takes about 15 minutes about 15 minutes to reduce the speed from about 1700 meters per second to 0. And also the altitude to 0. So this is the soft landing process. This is the first soft landing of China on the moon. But also the only second soft landing on far side of the moon of the whole world, also of China. So we landed on what they call the South Pole Aitken Basin.
So, Dr. Yang, I'm going to stop you right here because we have been receiving some questions from our audience about the South Pole Aitken Basin.
Yeah.
Like, why is this part of the moon so important? Why do we choose to
Or we
land?
call it SPA.
What is the scientific value of
No, the
this
scientists
region?
just call this
that
SPA.
even in the whole solar system, the South Pole Aitken Basin is a very huge basin.
Right.
Even comparing with,
It's a large area.
The moon is the 5th largest moon. Comparing with the moon of other planets of the solar system.
In a solar system.
But still, that's the diameter of this South Pole Aitken Basin is more than 2,500 kilometers.
That's the largest,
very
largest impact crater.
So, that the South Pole Point is included in this South Pole Aitken Basin. And it is formed about several billion years before by a small celestial body with a diameter more than 100 kilometers.
So it's the oldest.
Isn't it the oldest? The giant impact.
It's one of the oldest, and it's the largest impact crater within the entire solar system.
Wow.
Almost in the total, exactly. So, because that not also like the Earth, the moon have a crust, have a mantle, and have a core for this kind of celestial bodies. That until today, we human beings cannot get the substances from the mantle of the Earth because it's too deep from the surface of the Earth. But with the help of this 100 meter diameter celestial body several billion years before, it hit on the moon and maybe get the substance from the mantles to the surface of the moon.
That's right.
And also, although the South Pole Aitken Basin is very, very huge, also our Chang'e 4 probe landed in this area. Called
this area as well,
right? Crater. It is several hundred kilometers away from the landing point of our Chang'e 6. So this time we choose a different place because from the aspect of scientific research, we can get more meaningful results from a different place. And that this time we choose the Apollo Basin. It is a smaller basin inside the South Pole Aitken Basin because that with the help of another small celestial body, it can go deeper into the South Pole Aitken Basin. And if we are lucky enough, maybe the scientists can get the samples from the mantle of the moon.
Yeah.
Wow.
If it comes true, this will be the first time of human being get the samples directly from the mantle of a celestial body.
Right.
You can see how magnificent
you can see that picture just
This one,
on this
right
whiteboard. That was the crater. That was a very typical picture for it on the surface of the moon. There were still lots of the craters.
Yes.
Is it one
So
this is mission?
This is a picture taken from the video captured by the landing camera of the Chang'e 6 lander. Probably it is here.
It's under the probe.
Underneath. So you can see that on the far side of the moon, there are full of craters, impact craters and basins. The terrain is much more complex on the near side of the moon. So that is why it is so difficult.
Yeah, that's the most interesting part because for any kind of this lunar missions, there will be the engineers, the rocket scientists, and also for the planetary, the scientists who will be studying a planet. And they will fight each other because the rocket scientist wants to land on some very safe zones to keep to make the mission successful. I want to plan on this flat and plane, but all of the scientists they want to get in the deep to the crater. They want to get into the basin. That's right, and they will fight always.
You are my enemy.
Right.
Yeah. So
exactly.
This time, that for landing on the far side of the moon, the trajectory is quite different from landing on the near side. So for the Chang'e 3 and the Chang'e 5 probe, the trajectory can be very, very gentle. But from the Chang'e 4 and for the Chang'e 6, the trajectory must be almost go down directly
to the surface.
Perpendicular direction. So that will need more energy, more propellant. So that is why it is difficult. And so we landed successfully in this Apollo
crater,
Apollo Basin. And we within 2 days, we get the samples. And why it is more complex than the Chang'e 5 mission? You know that it is on the far side of the moon. We cannot see that. You know that in China, we have the Kashi ground station, we have the Jiamusi ground station, we have the Sanya ground station. And also, on the other side of the Earth, we have the Argentina ground station. Exactly. With these stations, we can help the Chang'e 5 lander and monitor the whole sampling procedure. But this time, you know, it is on the far side of the moon.
Right.
And all these ground stations can do nothing to help the probe. So the only
I think we have another question about that. Something we're talking about is this, we're talking about CHANG satellites.
Exactly. Yeah, we actually have a question about CHANG. Like, it's saying that how does China's launch of the CHANG 2 satellite contribute to the maintenance of communication with the Chang'e 6?
So let me.
So it echoes what you are talking about.
Tell you the answer of this question. So you know that we already have the CHANG or the Magpie Bridge data relay satellite for the Chang'e 4 mission.
Yes.
But you know it is far from the moon. So this is the Earth. This is the moon, and the CHANG 1 is more than 50,000 kilometers from the surface of the far side of the moon. So it's far from the moon, so the data rate of the communication is limited. So this time, we choose another way. So this time, the Magpie Bridge 2, or the CHANG 2 data relay satellite, was launched into a different orbit.
Can you show us where is the CHANG?
It is lunar orbit called frozen orbit, which means that like this way.
So this is an orbit.
So this is orbit. It is an elliptical orbit, and also the inclination is about 54.8 degree. The inclination of this orbit, and the advantage of this orbit is that the highest point of the apollonia does not change, because you know that this can save a lot of energy. And you know that the highest point is about 12,000 or 13,000 kilometers from the lunar surface. So it's much more closer to the lunar surface than the CHANG 1. So the data rate or the communication can have a more convenient communication with the probe on the far side or south pole of the on the moon. So this is an advantage, but it also has one problem. You see that for the CHANG 1, it can see the probe all the time.
Yes.
But this time, you know that it is a lunar orbit. Because it is elliptical, so it is the period of this orbit is 24 hours. But in most of the time, it is just above the landing area of the Chang'e 6. It can provide communication for 21 hours.
So it's not stationary. It's not a stationary orbit.
It's not a stationary orbit. It's always changing its direction. But for another 3 hours, we cannot have. We lost the contact.
So we lost the signal for 3 hours.
Yeah, we lost the signal for another
day.
Just blind.
Yeah.
So that is the reason this time the sampling procedure of our Chang'e 6 is much more autonomous comparing with Chang'e 5.
You have to rely on its own.
Exactly. So we designed, although the hardware is similar, but the software is greatly improved. You know that this time we designed 17 standard procedures, completely autonomous. So even without the help of the ground staff, we can get the samples. But of course, where to get the samples is the decision of the ground staff. Because you know we have the spectrum analyzer, which can get the image of the moon. We can in the vicinity of the lander, and we can get where to get the samples is probably most valuable. So this is the direction of the ground staff. But the whole procedure to get the samples, we can go that very automatically.
Okay, so this actually gets to another question just came in from the audience saying that why sampling...
No, before that, I want Dr. Yang to hear this comments and say, hey, hi NASA, are you also taking online classes with me to learn how to land on the moon?
That's interesting.
As we mentioned, this is our fourth landing, soft landing on the lunar surface, and also the second one of the world and of China to have the soft landing on the far side of the moon.
Right, that was the first time for a human to do something like that, on landing on the far side of the moon.
Yeah.
So, not to mention they have to take off and come back to Earth.
So after get the sample, you know that the design period is 2 days, but we do accomplish that much faster than that. So after get the samples, we probably seal the samples in a container and then prepare to lift off.
Okay.
So because you know that I am a technician, for me, the most nervous part or the most dangerous part for me is the lift off from the lunar surface.
Why is that dangerous?
You can see that we just not only lift off from the lunar surface. We have to lift off and to rendezvous and dock with another spacecraft.
The orbiter returner combination.
Exactly. So you know that the basic requirement for this kind of operation is that the chasing spacecraft must entering the example orbital plane of the target, of its target. So this is essential requirement, very, very important. If you know that the orbital speed is extremely high, if even a slight error happened, you do not have the chance to meet with your target. So that is why it is difficult. But this time it is more tough on comparing with the Chang'e 5 mission. You know that for the Chang'e mission, because it is on the near side of the moon, we can see that our Kashi, Jamus, Sanya, and our Argentina station, we can see the vendor of the procedure. Also, you know that we have very good astronomical observatories in China. We have one in Beijing, Shanghai, Urumqi, and also in Kunming. So these 4 observatories in China form a shape, and this can conduct what we call the VLBI, or the very long baseline interferometry. With this measure, we can have a very, very precise measurement of the orbit and also the coordinate of the landing site. So this is the advantage of the system we adopted. But think about it. When it is on the far side of the moon, it doesn't work.
Yeah, it's out of sight.
It's out of sight. It's out of all ground stations and all observatories on the ground. So for the
just one question is, the Magpie Bridge 2 can help us to observe something?
Quite right. So the only measurement for Earth is the Magpie Bridge 2. But in our professional field, usually that to determine or measure an orbit or coordinate with one single station is more worse than when you use multiple stations.
Right.
So of course, we have so many stations in China and abroad. So the orbit determination and also the coordinate of the landing site is much more precise than the Chang'e 6 probe. So, on one hand, we have a very high, extremely high requirement to the accuracy of the ascending the orbit, the trajectory. On the other hand, we only have a very, very limited support. So that is the reason why it is so risky, why it is so dangerous. So now you can understand as a technician why
you were like so nervous when you lifted it off, right?
So also, it is challenging. But after this,
what time was that?
About the 3rd of June or the 4th of June.
Like 2 weeks ago?
The 2nd of June.
I think it's 2 weeks ago.
The docking actually happened on June 6th, as I
June
remember.
6th.
So it's about 2 days before
2 weeks ago.
the liftoff. So for this mission, although the hardware of the Long March 6 is quite similar to that of the Chang'e 5, but this time we have a great improvement in all aspects, including the software, the whole system of the Qiqiao Magpie Bridge 2 relay satellite, and also the rendezvous and docking. And then after the liftoff, the ascender will take with our valuable samples, will entering the orbit, circumlunar orbit, about 200 kilometers high, and then it will wait there. So this moment, it becomes the target, and our combination, as you mentioned, the returner and orbiter combination will become the chaser. So it will chasing the ascender, one circle by one circle, and closer. Finally, they will use all kinds of, for instance, the microwave radar, the LiDAR, and also optical sensors to measure the relative different distance, the relative velocity, the direction, and also the other parameters. So come closer, and finally they can dock together. And then transfer the samples from the sender to the returner.
Yeah, to the combination.
Yeah, exactly. So this is the most risky part of the mission. This is called the lunar orbit rendezvous. Why we use that? The reason comes from here. Look, when you are are in a circumlunar orbit, then you need to soft land on the lunar surface. As I mentioned, the circumlunar velocity is 1.7 kilometers per second, very high velocity. So if you want to have conduct a soft landing, you must reduce this to 0, and also the altitude to 0. So this procedure will exhaust a lot of propellants, usually more than half of the total mass of the spacecraft. So this is exhaust a great amount of energy or propellant. And if you want to lift off from the lunar surface, also almost the same situation. So you can see landing on the moon and also lift off to the circumlunar orbit, you need so much energy. So if you take the returner to this procedure, it will waste a lot of energy. So that is the reason the returner is waiting in the circumlunar orbit, so it can save all the energies needed for that. And also, the ascender do not need to have the thermal protection for the returner. So with this procedure, also very similar to the Apollo program, we can save most of the energy and have the highest efficiency. There is we can compare with lunar sample missions of the former Soviet Union. You know that they have the three successful Lunar 16, Lunar 20, and Lunar 24. The three missions. All these three missions, the total sum of the mass of the sample they get is only 300 grams. You know that the probe of the former Soviet Union is 5.8 tons. Not very smaller, not much smaller than our Chang'e 5. Chang'e 5 is 8 tons. But even one single mission of the Chang'e 5, we get samples 5 times greater than the sum of all the samples they get. So you can see how high the efficiency is adopting this very complex lunar orbit rendezvous. So that's the reason.
So we have been like improving from generation to generation.
Exactly. So, and also with this technology mastered, it will be also very helpful for the potential manned missions to the moon.
That's right, and because we have this just this comments coming in. It was from the Haruto's Suna or Sana. I'm sorry to. It's very hard to pronounce this name, but it says, is this the mission meant to simulate the future manned mission?
Quite right. Because we China already mastered the lunar orbit rendezvous.
Right.
And also, I should emphasize, we are the first countries in the world that conduct unmanned automatic docking on the circumlunar orbit. So this is important.
This time in sample, but next time.
Although you know that's this more than half a century later, but you know that with astronaut inside, it's easier than Earth. So this time we've already mastered this technology. So even the guest like you, Meiping, you can sit in the lunar lander and you don't need to do anything. Just with automatic docking, you can visit the moon. So that's
looking
amazing.
Forward to that.
So now we've already get the samples and safely take the valuable samples to the returner. So it will now wait in the circumlunar orbit. So after about 2 weeks, the moon comes to this place.
Which
to this place. So because the moon is orbiting around the Earth. So at this moment, it comes to
just to remind us, the whole mission just take like 1 month time?
Nearly 2 months.
Nearly 2 months.
53 days. 53 days. So at this position, it is right moment for the returner to go back to the Earth. So at this moment, from the circumlunar orbit, we'll use the main engine of the orbiter to accelerate it and raise its highest point, or the apolluni. And then finally, it will escape the gravity of the moon and come into the trans-Earth orbit. Trans-Earth orbit. So it is also very similar to the translunar orbit. It's a very long, very narrow orbit.
Back now.
So it now goes back to the Earth. So also takes 3 to 5 days. And also in this process, very similar. We also have some mid-course correction. Mid-course correction. And then finally, the returner separated from the orbiter and then go back to 四子王边那儿. So that's a complete...
Wow, that's a successful mission.
Yeah. So you can see how complex it is. The whole mission profile, 4 spacecrafts. So several separations, several dockings. So why it is also with the coordination with the Magpie Bridge.
So there's a question for you actually, Dr. Yang. So what is the highlight for you during the whole process of the Chang'e 6 lunar mission? What do you think is the biggest highlight?
I believe, as I mentioned and emphasized many times, the most important highlight is the liftoff from the farthest moon.
Okay,
because the requirement and also because the restraints. So it is challenging, but we get what we want.
A lot of the comments are talking about is their anticipation for the future manned missions. Yeah, and
the 2030 China has a plan for the 2030 manned lunar mission.
Yeah.
As I know, until this moment, I've already have 3 taikonauts expressed their wish to
go to the moon.
Walk on the moon. Miss Wang Yaping, first one, and Miss Liu Yang, the second one, and also the third one, Mr. Zhang Lu.
Just 3 of them? Just 3 of them? I think all of them are wishing
including
to.
me, I can go too.
Everyone wants to get on board.
If you are rich enough. That's just about in 2011, during the coverage of our CGTN, that time called the CCTV News.
Yes.
We talked to our anchor that the astronauts should eat mooncake on the moon.
We will, I think.
And I expressed
in 2030.
And I expressed my wish to Yaping. I hope that she can eat mooncake because it is our traditional Chinese delicious food. And
for the Mid-Autumn Festival,
eat mooncake on the moon will be very interesting.
And who do you think have the best chance to be selected? To be,
you know that Mr. Yang Yiwei, our space hero, has mentioned that all the taikonauts attending the lunar manned missions must have the experience to stay in our Tiangong space station. That's very necessary and also very helpful for them in the future. But you know that for lunar missions is more challenging, although it's much shorter than the Tiangong space station missions, but more dangerous than that. You've already seen this whole procedure. And even one slight error can cause the failure of the whole mission. Also same as the future potential lunar mission, because you know that for the future manned missions to the moon, we also choose the lunar orbit rendezvous. We will have, not like this one, we will have 2 launches. The first is to launch the lander with one Long March 10 rocket to circle around the moon and wait there. And then the second launch to the new generation called the Mengzhou spacecraft with 3 astronauts, also the same road to the moon and go to the circumlunar orbit and rendezvous and dock with the lander. And then 2 astronauts will transfer from the spaceship, from the Mengzhou to the Lanyue lander.
Right.
And then land on the moon. Take samples, eat mooncake, and then go back. And then transfer the samples and also themselves to the spaceship and then go back. So you can see the whole procedure is quite similar, but it's only 2 launches.
Okay.
Well, just as Dr. Yang just mentioned, so this is a question for you, Artemis and ILRS tracker, who wish to know when might we expect to see test emission for Mengzhou and Lanyue respectively.
Well,
you have any news?
According to the formal announcement of China Manned Space Agency, all taikonauts will walk on the moon before 2030. But you know that although it is not formally announced, you know that from the view of an engineer, you know that before that we must have manned missions first to test the safety and the feasibility of our spacecraft, our design, and the whole system.
Yeah, stay tuned with CGTN if you wish to know any of the further steps, like the test emission. We will cover that when it was officially announced about Mengzhou and Lanyue, respectively. Well, that was apparently that was the Artemis and ILS tracker. I think is the Western user of the CGTN, who has been very clearly about this, the roadmap of China's future mission. You know, the Mengzhou and Lanyue and the spells, correct? Well, that's
and we
amazing.
also have a question about, we know that China has planned to build a moon base.
Yeah,
you know,
which is called, what you mentioned is called the International Lunar Research Station. But of course, first this will be a robotic or a manned station in the South Pole regions. Why to choose the South Pole? There are 2 reasons. You see that for the spacecraft on the lunar surface, it is extremely crucial condition. With the temperature, the highest temperature can reach to about 150 degrees Celsius.
The difference is like really big.
And during the long and tough lunar night, the temperature can be below minus 180 degrees Celsius. So It's very
temperature
powerful.
different is about like 300. 300
the
degrees.
difference is more than 300 degrees
300
Celsius.
degrees.
But you know that in the South Pole regions, it is amazing. There are some almost nearly permanent sunshine areas. So in these areas, it's easy for your thermal control and easier for you to get energy, to get electricity. More important thing is that near these kind of permanent sunshine areas, there are also some permanent shadow areas. And probably in these shadow areas, there are water in the ice form. So you can get these resources. So that is why the lunar surface, all the space capable nations choose the South Pole as their location of their base on the lunar surface.
Our director just created a new tag called 余光老师航天课.
That's the space lesson of Dr. Yang Yuguang.
So you two want to take some breaks? You've been talking a lot. It's the 4:45.
Have some water.
Yeah,
Okay,
sip some
thank
water.
You, thank you. So we can hope that we can get water from the
Right,
lunar surface.
and I just want to take this this moment when Dr. Yang is taking some break, and I want to show you these things.
What is this?
Which camera should I? Should I be this one? Okay. This is the lunar. It's a picture. It's the microscopic picture of the lunar soil sample. I was given by one of my friends, who is the scientist, who are very, very fortunately to get the sample, to apply to the sample, because lots of people have been asking online about what do we do for when we get this the lunar samples. Well, the truth is that after we get this samples, no matter in the Chang'e 5 mission or this time for Chang'e 6 mission, they will go back. All the scientists are from all around the world. If you have any ideas on study and research about the lunar sample, if you want to learn more about the moon, you can file the report to Chinese government to apply for the lunar sample. So this is one of my friends who's been looking for the CAS, the Chinese Academy of Sciences, who has been very, very lucky to apply for some of the samples, and they take this picture, microscopic picture, just like that. It's very, very beautiful. It's actually
different than what I thought before.
Right,
It's not
here are some
rocks.
and some of this introduction about this sample. It seems to be, well, this is all written in Chinese, but it seems to be this is the glass. This is the glass.
I thought there's a QR code over there.
Right, and that's something very interesting I want to show you, because I think the significance of the lunar sample and on whole Chang'e 5 or Chang'e 6, and no matter it's the Chang'e series mission, is we're not only develop the rocket science or our planetary science, but it's actually encourage all societies to get involved. This is the sample, and some people are getting this sample, and they have created this very QR code.
I'll hold this for you.
Yeah, I can just scan that, and to show you what can we do
with
this picture. All right, it's actually a AR interaction. It's like a video games that you can scan, use your phone. Just here you go.
Okay. Again?
I don't know if we can see that. We can use this to scan this picture, and now here you are. You have the samples on your cell phone screen, and you can zoom in and zoom out.
It's the same, right? It's the same as the picture.
You can spin the 360 degrees. You can see every detail, check every nook and cranny of this lunar sample right here. Just pretend that you can hold this on your hand.
So you can take a picture with the lunar sample,
kids like that. Kids like that. All of the kids and the students in the class. So this is not just for science. This is not just for the engineer. But it's also about how to inspire our kids, our children to get involved in this. So they want to learn more about this lunar. And you can use this kind of application. There's a lot of the application. There's a lot of the expos that you can find in China.
I think it's also implying that the lunar exploration is not just about the science, as you said.
Right.
It actually can impact our daily lives in the future because of the study, like the research of the samples.
Right. That was, and also what's amazing is you can take a picture with the lunar sample if you wish.
Like that, like
hold it like this. Check this. Check this. I think maybe you can hold this.
Okay.
And hold this.
Is that red place? At the red place?
There you go. Here you go. Haha. Okay.
Remember to send that
picture.
to me after the session.
Right, we got this picture. Okay.
Actually, our audience want to know more about the lunar samples. Like, there's a question saying, like, what do scientists hope to learn about the moon from the samples? Like, what can we actually learn from the samples we get from the far side of the moon around the South Pole Aitken Basin?
Well, you know that the total area of the moon is about 38 million square kilometers. It's only a little bit smaller than our Asia continent. So you can see how many geologists have already get samples from Asia. Maybe thousands or even 10,000 of samples. So today, and including our Chang'e 6 mission, we only get 11 times samples. So still, I think we still have a very long way to go to get a more comprehensive understanding of the moon. But you know that all the previous 10 sample return missions all come from the near side of the moon. So that is why this Chang'e 6 mission is extremely meaningful for all of us. For not only for China, but also for other countries in the world. And moreover, you see that we can compare with the Chang'e 5 mission. With the Chang'e 5 mission, we already get more comprehensive knowledge about the evolution of the moon, especially the volcanic activities of the moon, much younger than expected before, than the traditional series before. So this is the help of the Chang'e 5 mission. But you know that we only have little information about the far side mission, because just before this Chang'e 5 mission and also our Chang'e 4 mission, other countries can only get the images, remote sensing information from their orbiters to the far side of the moon. But this can get a very wide range, but not very detailed or concrete information on the surface. So we not only need orbiters, but also we need the lander and the returners. So this time is the first time. I don't think this will be the last time. I think in the future, the human being will get more samples from far side of the moon. And also, because you know I'm an engineer, I'm not familiar with the scientific research methods of those in the China Academy of Science. But you maybe have interviewed with them. So in the future, they will use all kinds of powerful instruments on the Earth, their scientific research instruments and the facilities to study the samples of Chang'e 6.
As you mentioned the picture, I remember there's a mini-rover on board the probe. And I remember reading a question like, what does the mini-rover do besides taking a selfie?
Exactly. So you know that this minimized rover is just being used, why it can come true, because we also have designed the margin of the Chang'e 6. So the capability of the Long March 5 is greater than we needed. So we can have a designed margin, we can have more payloads on the lander. So this time, this small rover is, or a robot is utilized as a piggyback payload. So it can separate from the lander and go to a distance and then take pictures of the lander.
So it's
and then it will be left over on moon?
You know that it is a very...
Can it get back to the, to the lander?
You know that not only it cannot get back to the lander, but also you know that it cannot get their image directly transferred to the Earth. Because it is too small, so it can only transfer the image, the data to the lander, and then back to the Earth.
That was this disposable probe.
Yeah.
It's a little sad, actually.
You know, the similar thing also happened to our Mars rover.
Right.
The Tianwen.
The Zhurong rover also have similar measures to take the selfie.
Right. There's a lot of people who are very curious about China's other space mission. So we can just walk you through all of that. Because the Chang'e series is it's about the moon. So now we have the Chang'e from 1 to now is 6. And just 2 hours ago, we just have finished the Chang'e 6 mission. And after that, we still have those Chang'e 6, 7, 8, and 9. And then we'll have the lunar base and a manned landing missions in the coming few years, hopefully before the 2030. So that is the Chang'e for the lunar mission. And also we have Tianwen but Tianwen is not exclusively.
It's a Mars mission.
But it's not only for Mars, right? Tianwen is a
actually
serious
only
mission
for Mars.
It's completely for Mars.
For Mars.
For all. Because you know that in the Tianwen mission, we combine orbiter, a lander, and a rover in one mission. You know that until today, China and the US are the only two countries that can safely land on the Mars surface and conduct scientific research. No exceptions. So the other countries all failed during the landing process because it's more challenging than landing on the Earth or on the Moon.
But I remember this Tianwen is the bigger mission to including all of the planets within the solar.
Because
the Tianwen.
Actually speaking, the Tianwen probe is the heaviest manned probe of human being to the Mars. But because you know that it combines the orbiter and also the lander and the rover. So the rover is not the biggest one, but it is the biggest rover based on solar powers. Because you know that the Curiosity and Perseverance are bigger than our Zhurong rover, but they are nuclear powered. Not solar powered. So the Zhurong rover is the biggest solar powered rover on the Martian surface.
I remember hearing that the Zhurong 2 is actually on its way, like in the next couple of years.
You know that.
I mean the Tianwen 2 mission.
Tianwen 2
mission to the Mars.
Will be asteroid sample return mission. So we will get samples from the what we call the near Earth objects.
Yes.
So we will not only get the samples from the near-Earth objects, maybe a comet or an asteroid, back the samples to the Earth, and also the orbiter will go deeper into the main belt between the Mars and Jupiter. So we'll hope that it can get more samples, get more information.
Yeah, so it's a little bit difficult for our audiences who's not native in Chinese, because there was a lot of Chinese names to memorize.
Deep meanings,
right.
cultural
Zhurong
meanings.
is the god of fire.
The god of fire is the Zhurong. So
not like Prometheus.
Yeah, because we in Chinese, Mars is called 火星. It's like
so it's about fire.
It's about fire.
The star of fire.
Yeah, so we pick up the god of a fire to name our the rover of the Mars.
Like the CHANG E mission is the goddess of the moon
so
in
the
China.
CHANG E is the Diana.
It's our Diana.
Diana, Artemis of China.
It's Artemis. And also you may have heard a lot about Tiangong. Tiangong is China's space station.
It's the Olympus of China.
So Tiangong is also, I think the three is enough for you to memorize.
Romantic to put some cultural meaning behind the scientific objects.
Right. Actually, we just talked about lunar samples. After this mission is completed, the next job is for the scientists to do their research on a lunar sample that has been brought back by Chang'e 6. Actually, I just talked to some of the scientists in China about their anticipation about this new samples. They're really excited about that, and I was told that the Chang'e 6 and Chang'e 5 are some sort of a relay research, because the Chang'e 5, as Dr. Yang just mentioned, are extracted the samples from the front side of the moon, and this time we get the sample from the back side of the moon. So if you only have the front side of the moon, you cannot understand, or you just have if you only have the far side of the moon, you cannot have the whole picture of this the evolution of the moon. Now you have the two samples, and this is for the first time I think human beings can figure out something more mysterious about the moon. So here we have a video to tell you what do we know about the moon after we have the Chang'e 5 mission. So we have to do lots of research, because that was 3 years ago. So we have like 3 years to do the research on the Chang'e 5 mission, lunar sample. So now we have make some new knowledge about the moon's evolution. So let's check out this video.
Last December, China's Chang'e 5 mission returned 2 kilograms of samples from the moon, and marks the first time in over 4 decades rocks from the lunar surface were brought back to Earth. After months of study, geologists have uncovered more secrets about moon.
And then the 3 papers from my institute, IGG-CAS. First paper dated the first age, establishing this 2 billion year old age. And our results we're quite proud of is very precise. Even though we're talking 2 billion years ago, the uncertainty on our age is only 4 million years. Very, very small.
Prior to China's latest mission, the youngest lunar sample scientists have ever laid hands on were the ones from NASA's Apollo missions in the 1970s. which were dated just shy of 3 billion years old.
The obvious biggest difference between the new samples from Chang'e and Apollo is their age. So this extends the lifetime, if you will, of volcanic activity on the moon almost 1 billion years.
The Chinese samples were collected from a basalt area on the moon known as Oceanus Procellarum, a region untouched by any human expedition. Previous studies suggest the region was formed in lunar volcanic eruptions billions of years ago. That means the basalt sample initially emerged from the moon's interior in the form of magma way back in ancient times.
You know, volcanism is really kind of the meter stick for knowing if a planet is alive. But when we take the pulse of the moon, we're really looking for the last large volcano.
That said, the Chang'e 5 lunar samples have extended the lifespan of the moon as we know it for almost 1 billion years. But the revelation also raises more questions. Compared to Earth, the moon is much smaller and lighter. It has no atmosphere and an almost non-existent magnetic field. There is just no way that it could have preserved its heat for so long, or should have cooled down a lot sooner. But plenty of evidence now suggests otherwise. Why? Scientists thought the radioactive elements detected inside Moon's regolith might be the answer. They had been providing Moon with lots of heat, allowing the mantle to melt much easier. These radioactive substances are collectively known as creep.
One of the reasons we picked this spot was because it was in the creep terrain. So what is creep? The K stands for potassium. REE are rare earth elements. And the last thing is phosphorus. But the most important is the K, because K is one of those radioactive elements. And from the orbital observations, we know that there's a lot of heat-producing elements at the surface of the moon. But then the question comes, do you have the same amount of heat-producing elements in the mantle? Because that's where you need to melt the mantle to create the volcanism. So what they found is even though the rocks at the surface are very rich in this heat-producing elements, when it comes down to the mantle source, they're very, very low.
A classic explanation of the moon's prolonged volcanism is thus proven wrong. And then another theory surfaced. Water, the source of all lives. Scientists say a lot of it might be held in the moon's mantle from ancient times.
If you add water to a rock, it will typically melt at a much lower temperature than if it didn't have water in it. There are some measurements from the Apollo era where the mantle of the moon had as much water as Earth's mantle. But there were also other measurements where it was much, much drier. And that's where Chang'e 5 came in, and being the youngest one, which one is it going to be? Is it going to be the wet type or the dry type? If it's the wet type, then yeah, water could be part of that explanation.
The result of Chang'e 5 sample shows the basalt samples contain very little moisture, suggesting the mantle of this area was bone dry at the time the rocks was formed.
At the young age, there's not enough water to lower the melting temperature and give us the volcanism. So another idea that we have to abandon for these basalts.
So what exactly has kept the moon alive for so long? That has yet to be figured out by scientists. But the answer will change the way we understand the moon's chemical and thermal evolution.
And that's kind of the most exciting thing that's coming out of Chang'e 5 is a new dilemma to answer. You answer one question and a new one comes up.
Well, can't believe it's been 1 hour. This is really fast. We've been talking a lot about his engineering challenges of the CHANG E 6 missions. We've been talking about the lunar samples and what potential outcomes might be from the far side, the far side moon, the lunar samples, and also I think another thing we have to mention about is the significance of this mission is the international cooperation, especially for the CHANG E 6.
Yeah.
And this time we have, it's not only for the China's the payload, but also we saw the multiple payloads that from other countries and other organizations. Well, so far as we know, we have the payload from the France, from the Italy, from Pakistan, and also ESA.
Yeah, exactly.
Right.
So you know that this time, especially the lander, our CHANG E 6 lander takes 3 of the payload you mentioned. For instance, the France provide us the return detector. You know, return is a rare gas. It's the most heavy rare gas. And also it's it has radioactivity. So measuring the return, the components will be helpful for us to get some very important evidence of the gases distribution and other parameters on the lunar surface, the environment. And also we have the negative ion detector from the European Space Agency.
Yes.
So this is also very important for us to get more comprehensive knowledge of the moon. You know that Italy provides us laser retro ranging reflector. It is very interesting. You know that my friend Buzz Aldrin, the first crew member to land and walk on the moon, he just placed the LRRR, or called laser ranging retro reflector, on the lunar surface, on the sea in the Sea of Tranquility. So even today, including our astronomers from the Shanghai, from the Yunnan Astronomer Observatory, they utilize this LRRR to measure the precise distance between the Earth and the Moon.
Right.
So.
But this time it's on the far side.
So this time it's on the far side. Today we don't have the laser, but sooner or later, this will be the first benchmark of human being set on the lunar surface. On far side.
That will be a very
you know that we
valuable
already
insight.
have the retro reflector from the Apollo 11 mission, from the Apollo 14 mission, and maybe Apollo 17 mission, and also from the Lunar Code 1 and 2 from the Soviet Union. We've already have 5 on the near side. Now this time is the first on the far side, but made by Italy and brought by Earth to the lunar surface. And moreover, you see that the orbiter take a CubeSat made by China's universities and Pakistan to the circumlunar orbit. So also very meaningful. I can still remember that more than 30 years before, in 1990, during the maiden flight of our Long March 2E, it is testified, so do not have a real payload, but we do have a piggyback payload. It is the first satellite of Pakistan. In 1990, we launched the first satellite of Pakistan into orbit, and this time we launched the first lunar orbiter of Pakistan. So also very meaningful.
What are foreign scientists' expectations from China's CHANG E 6 lunar program or our lunar exploration program?
Well, you know that as Yang Zhao has already mentioned, in the future we will establish our International Lunar Research Station. So very interesting that the CHANG E 4 mission also we classify that into the 4th phase of our lunar exploration project. And also this time we have the CHANG E 6 mission. In the future, you know that the CHANG E 6 landed in the latitude about 40 degrees to the south. But in the future, the CHANG E 7 and the CHANG E 8 will land in the polar regions, in the South Pole regions of the Moon. And they will choose that point as the future location of our lunar research station. Also, very interesting, not only Russia, but you know that last time during the IEC in Baku, in Azerbaijan, my friends, Mr. Asadov, Mr. Samatin Asadov, the president of the Cosmos, or the space agency of Azerbaijan, also choose to join our International Lunar Research Station.
Yes.
So already we have Thailand, we have Azerbaijan, and some other countries already joined our program. So in the future, I believe that we can have more friends from all over us. Not only those space capable nations, but also say space emerging countries like Azerbaijan to our lunar research stations. So I hope that in the future we can have more communications and bring more cooperation chances with our friends.
Exactly, as some of the Western media prefer to use the words like the space race. That's not how China see this mission. We call this mission a chance for everybody to work together. This space is for everyone, each and every one of us. So we invited more people to get on board to explore the space and to find out a mystery, and also and for the future of the whole human beings. That's right. And thank you so much for watching. I'm gonna to wrap up today for our live show. This is The Hype. Thank you so much. And once again, for Dr. Yang Yuguang and my colleagues Mei Ping.
Goodbye.
Thank you so much, and see you next time.